Subscribe our Nehra Classes YouTube channel to watch free live training sessions and to avail the membership facilities and additional perks, click the join button. Hello everyone, I Vikas Nehra welcome you all to session number 43 of our ongoing RHCSA version 10 training. In this session, we will talk about RAID in Linux. So in this session, first of all, I will give you the idea about RAID. We will talk about different types of RAID labels, their advantages, disadvantages, and uses. After that, I will explain the working of each type of RAID label. And then I will show you how can you configure RAID in your RHEL 10 machine and how can you manage it. So for that practical tutorial, I will use my RHEL 10 machine where I will use 2 disks to configure RAID 1. Then I will create some data on the RAID. Then I will make one of the disks faulty, and then I will remove that disk from the RAID and replace it with a new one. And I'll show you that the data will remain intact. At the end of this session, I will give you the exercise to configure all the remaining types of RAID labels in your respective machines. So let's start the session with the introduction of RAID. What is RAID? RAID stands for a redundant array of independent or inexpensive disks. It is a storage technology that combines multiple physical disk drives into one logical unit for improvement of the performance, redundancy, and both. RAID can be categorized into 2 categories: physical RAID or software RAID. In physical RAID, we use multiple storage devices or the drives, physical drives, and we manage them using the firmware. While in software RAID, we do this from the operating system. So I will show you how can we manage this software RAID in this session. If I talk about different RAID levels, we use RAID 0 for stripping. RAID 1 works on the principle of mirroring. RAID 5 works on the principle of stripping with parity. RAID 6 works on stripping with double parity. And RAID 10, it works on the principle of mirroring and stripping both. That means it is a hybrid RAID. Each one out of these has its own advantages, disadvantages, and uses. So let's talk about each RAID level in detail. First, I will talk about RAID 0. As I mentioned earlier, RAID 0 is used where we need high performance. So what happens in RAID 0? Data is stripped into multiple disks. So how many minimum disk drives are needed to configure RAID 0? The answer is 2. We need minimum 2 drives. If we are using 2 drives, whether we will get the redundancy or not? No, we will not get the redundancy. That means if one of the disks become faulty, our data will be gone. The speed is excellent for read-write operations in RAID 0. Storage efficiency is 100%. That means we are using the entire disk space to keep the data. That means we can utilize the entire available disk space. Let us suppose we have 2 different disks, disk 1 and disk 2. So what will happen if we use these 2 disks to configure RAID 0? Our data will be stripped into 2 parts. Some amount of data will be stored in the first sector of disk 1. Some will be stored in the first sector of disk 2. Similarly, data will keep on stripping and keep on getting saved on these 2 disks. So data is split or stripped across drives for the performance. If I talk about the advantages of RAID 0, RAID 0 offers very fast read-write speeds and it uses 100% of the available disk space. If I talk about the disadvantages, it is not fault tolerant. That means if one disk fails, all data is lost. It is ideal for non-critical high-speed tasks like video editing, gaming, or where we need high performance. Now we will talk about RAID 1. Again, it requires minimum 2 drives to configure RAID 1. It provides redundancy. Speed is fast, but write speed is moderate. Storage efficiency is only 50%. Each disk in this RAID has the exact copy of the data on the other. Suppose we are having 2 disks in RAID 1. So each and every block of disk 1 will have the same data as each and every block of disk 2. That means both the disks will have the similar data. That means it will provide the redundancy, but it will provide us storage efficiency only 50% because we are copying the data on the other disk. That means the storage capacity has been reduced to 1.5. If I talk about the advantages, it is excellent for redundancy. It is simple to recover the data in this RAID. That means recovery process is very simple. If I talk about the disadvantages, we are only using 50% of the usable capacity. Such RAIDs are used for critical data, small servers, or personal backups. Means we use it on those situations where we value the data. If data is important, then we will use RAID 1. After that, we will talk about RAID 5. Here we use the concept of parity with stripping. It requires minimum 3 drives. It provides us redundancy for up to 1 faulty disk. That means it can withstand 1 disk failure. If I talk about the speed of RAID 5, it provides us good read speed but moderate write speed. If I talk about the storage efficiency is n minus 1 upon n, where n is the number of drives. That means in case of a 3 drive RAID 5, we can tolerate 1 disk failure. Suppose these are the 3 drives which we are using in RAID 5. So how the data will be stored? Some portion of the data is stripped and saved in the first block of disk 1. Remaining portion is saved in disk 2, and the parity or the checksum is stored in the first sector of disk 3. Similarly, the checksum of the data on disk 2 and disk 3 is stored in form of parity on disk 1. So parity is distributed for redundancy. If I talk about the advantages, it provides us a balance of speed, capacity, and redundancy, good for general purpose servers. If I talk about the disadvantages of RAID 5, rebuild after failure is slow. Performance hits on large arrays. And it is ideal for file and application servers with moderate capacity needs. After that, I will explain RAID 6. In RAID 6, we use double parity concept along with data stripping. So it would require minimum 4 drives. It provides us better redundancy and it can tolerate up to 2 disk failure. If I talk about the speed of the RAID, it provides us good read speed but slower write speed. Storage efficiency is n minus 2 upon n. That means on a 4 drive RAID 6, it can withstand up to 2 disk failures. How the data is stored? Suppose we have 4 drives in our RAID 6. So some portion of the data is stored in the first sector of first disk. Some or the remaining is stored in the first sector of disk 2. Then the parity is stored on the third disk and the copy of the parity is stored on the fourth disk. So here we are having an additional parity bit which is stored on the other disk. So that's why it can withstand up to 2 disk failure. If I talk about the advantages, it can tolerate up to 2 disk failures. Good for read performance. Disadvantages are write performance is slower, complex rebuild process, and such RAIDs are suitable for large storage arrays with high fault tolerance. After that, I will talk about RAID 10. We call it RAID 10 also. Here we use the concept of mirroring and stripping at the same time. So it would require minimum 4 drives. And you have to keep in mind that in RAID 10, we will use even number of drives. 4, 6, 8, like that. This RAID offers excellent redundancy, excellent read-write speed, but the storage efficiency is only 50%. This is the ASCII diagram where we are using 4 disks. So what is happening here? Our data is splitted or stripped into 2 parts, A1 and A2. Disk 1 and disk 2 are having the same data and the remaining data is stored on disk 3 and disk 4. So what we are doing? We are stripping the data and then at the lower end we are creating the backup of the data. I will explain with the help of the PPT the working of all these RAID levels. You don't need to worry about it. So first it mirrors. That means we are using the concept of RAID 1 and then it strips. That means we are using the concept of RAID 0. So both these RAID levels we are using here at the same time. That's why we call it RAID 10. If I talk about the advantages, it combines speed of RAID 0 with redundancy of RAID 1. Rebuild time is very fast. Disadvantages are it offers only 50% efficiency and it is more expensive since it requires multiple additional disks. It is suitable for high performance database and critical applications. You have to keep in mind that RAID is not an option for the backup. RAID protects us against hardware failures, not deletion or corruption of the data. Always maintain offsite backups. Use ECCRM, especially with RAID 5 and 6 to protect parity accuracy. Regular monitoring is required. So RAID failure without alerts, that means disaster. Controller matters. Hardware RAID is faster but costlier. Software RAID is flexible and cheaper. Here I have a table which can summarize all these RAID levels. You can obviously go through this table. Okay. Here I'm showing you all the RAID levels in different pictures. This is RAID 0 where we are using 3 disks. RAID 1 we are using 2 disks here. So in RAID 0 we are stripping the data, while in RAID 1 we are mirroring it. In RAID 5 we are using 4 disks. In RAID 6 again we are using 4 disks. And then RAID 10 we are using 4 disks. Now I will explain the working of each RAID level in detail. So let me take you to my PPT of RAID 0. And here I'm going to explain the working of RAID 0. Here To explain the working of RAID 0, I'm going to use two disks, disk 1 and disk 2. You have to keep in mind that in case of RAID, the disks must be similar. That means the capacity and the speed must be the same. So here we are using two similar disks, each one of capacity 1 TB. That means our RAID can offer up to 2 TB capacity. How the data will be stored? Let me show you. Suppose this data needs to be stored on the storage. We have a file where this Nehra class is mentioned and our computer wants to save this data on the RAID. So how it will be stored? Obviously, it will be converted into binary and then it will be stored, but it is just to make you familiar with the concept. I'm directly showing it with the help of the characters. So how the data will be stored? Out of this text, the first alphabet N will be stored in the first sector and first block of the first disk. Then E alphabet is stored on the first sector of the second disk. Then H is stored on the second sector of the first disk. R is stored on the second sector of the second disk. A is stored on the third sector of the first disk. C is stored on the third sector of the second disk, and so on. So our data is stripping into two parts and getting saved on different blocks on the different disks. So that's why here we are using the entire disk capacity. So the total disk capacity becomes double if we are using two disks. So this is RAID 0. Now let me show you the working of RAID 1. In case of RAID 1, we mirror the data. Data is mirrored. Let me show you. Here again we are using two disks in this RAID. And suppose I want to store this Nehra word on the RAID. So how the data will be stored? This N will be stored on both the disks. That means RAID 1 will create the exact copy of the data on both the disks. E is stored on the second storage block of both the disks. Similarly, H, R, and A. That means we are mirroring the data. We are creating a backup or the copy of the data on all the disks. If we are using two disks, the storage capacity is halved. The total capacity was 2 TB, but we are only able to use 1 TB. In case of RAID 5, what will happen? Let me show you. Suppose we are using three disks, each disk of 1 TB capacity, and in RAID 5 we use the concept of stripping with parity. Suppose we want to save this data on the RAID. So what will happen? Our data will be converted into stream of bits of 1 zeros. For this N character, suppose these 8 bits need to be stored on the disk. So first 4 bits of the data are stored on the first sector of the first disk, and the remaining 4 bits are stored on the first sector of the second disk. And after the parity bit calculation, their checksum is stored on a sector on the third disk. How this calculation is done? We use different techniques. Let's suppose to calculate the checksum, we are subtracting the remaining 4 bits from the first 4 bits. So it will give you the output 0010. If we will subtract 0101 from 1010, we will get the result 0010. So this data is the parity checksum. It will be stored on the third disk. And similarly, the parity checksum of the data of second and third disk will be stored on the first disk, and the parity checksum of the data on disk 1 and disk 3 will be stored on the disk 2. So this will help us to recover the data in case one of the disks become faulty. So the parity bits are very important in case of recovering the data. Suppose if disk 1 becomes faulty, can we retrieve the data back? Yes, we can easily do that because we have the parity checksum and the other portion of the data. We know that this parity checksum is the result of the subtraction of these two numbers. So with the help of these two, we can easily calculate the bits which were present on the disk 1. In case of RAID 6, we use an additional copy of the parity checksum with the help of an additional disk. So in RAID 6, we use minimum 4 drives. Let us suppose we are using 4 drives, each one of capacity 1 TB, and here we want to store this data on the RAID. So for this N alphabet, we have this stream of the data that needs to be saved on the RAID. So first 4 bits are stored on the first sector of the first disk, and the remaining bits are stored on the first sector of the second disk. So with the help of the calculations, we can calculate the parity bits. Suppose if we subtract the first 4 and the remaining 4 bits of data, so we get the parity checksum. So the parity checksum bits are stored on the third disk, and a copy of the same is stored on the fourth disk. So in case if our disk 1 or disk 2 becomes faulty, can we retrieve the data? Yes. In this case, our RAID can withstand up to 2 disk failure, because we are not only using disk 3 and disk 4 to keep the parity bits only, they keep the data bits also. The parity bit of the data of disk 1 and disk 2 is stored on disk 3. In the similar fashion, the parity bits of the data of disk 2 and disk 4 may be stored on disk 1. So a single disk can have the data bits as well as the parity bits. In case if a disk becomes faulty, we can easily retrieve the data. Our RAID will automatically rebuild the data, and this can withstand up to 2 disk failure. Okay, now I will explain the working of RAID 10. In RAID 10, we strip the data at the upper end and mirror the data at the lower end. So what happens here? We are using 4 different disks, each one of 1 TB capacity. For example, suppose I want to store this data on the RAID, and if I talk about the first alphabet, that is N. So these are the bits which are to be saved on the RAID. Let us suppose the first 4 bits and the last 4 bits, they will be stripped. They will be stripped at the upper end, but at the lower end, they will be copied. Means the first sector of the first disk will have the same data as the first sector of the second disk, because at the lower end, we are mirroring the data, but at the upper end, it was stripped. Similarly, in case of disk 3 and disk 4. So disk 3 and disk 4 will have the identical data, and disk 1 and disk 2 will have the identical data. So we have a combination here. In this case, disk 1 and disk 3, this set will have the complete data. And similarly, set B, that is disk 2 and disk 4, it will have a complete set of the data. We call it RAID 10 or RAID 10 because here we are using both stripping as well as mirroring. We call it hybrid RAID as well. And this can withstand up to 2 disk failure if they are not from the same end. It can withstand up to 2 disk failure if both the disks are from different sets. Okay. Now I will show you how can we easily configure and manage the RAID in RHEL 10. So this is the machine which is running on RHEL 10. This machine I'm going to use to configure and manage the RAID. You have to keep in mind that we would require a package in our machine with the name as mdadm. You have to make sure that this package is already installed in your machine. If not, you can manually install it by running the dnf install mdadm command like this. In my case, this package is already there. If you made the installation in the GUI mode, you will automatically find this package there in your machine. Okay. If it is not there, you can manually install it by running the dnf install command. mdadm is the command that we will use to configure and manage the RAID. So let's open the manual of this RAID command. mdadm manage MD devices like Linux software RAID. So what type of RAID it is which we are going to configure and manage? It is a software RAID. Hardware RAIDs require hardware devices. Okay, so this command will be used. You can obviously go through the description. You can obviously check the available options with the command, and you can check the examples as well. I'm not going in the details of the manual. I will explain you how can you configure it. So I'm going to show you all the commands which are required at the time of configuring the RAID and at the time of managing the RAID. So we would require some additional disks in our machine which we can use to configure the RAID. Here I'm going to configure RAID 0 first. After that I will configure RAID 1. So in case of RAID 0, we would require minimum 2 disks. So let's go in the settings of our machine, and here we will add 2 disks. We will click on add, then we will select hard drive, SATA, new virtual disk, store virtual disk as a single file, finish. Again click on add, hard disk, SATA, new virtual disk, store virtual disk as a single file, finish. Okay. So we have just added 2 disks in our machine, SDA and SDB. These 2 disks we will use to configure RAID 0. Okay. Let me show you how can we configure the RAID. How can we create the RAID? So we will use mdadm command to create the RAID. Here we can mention -C, capital C, to create the RAID. Then -V for verbose, so that we can see the details on the screen. After that, we will mention the name which we want to give to this RAID. RAID naming starts with /dev/md0 123 and so on. So this is the first RAID. So we will mention the name as /dev/md0. Then we will define the level of the RAID with option -L. So RAID level is 0. Then -N we will use to mention the number of drives that we are going to include in this RAID. So -N, and then we will write here 2. And after that, we will mention the names of the disks or the partitions that we want to use in this RAID. /dev/sda /dev/sdb. In case if we want to create the partitions and use them for the RAID, we can use the fdisk command first. But you don't need to create the partitions. You can use the raw disks if you want. So this will create the RAID. And we can check the details by running the cat proc mdstat command. RAID 0 has been successfully configured in our machine. If we execute lsblk command, we can see that on SDA and SDB, MD0 is mentioned. That means both these disks are the part of RAID 0. Now we can create the file system on this RAID. mkfs.ext4/dev/md0. This will format the RAID in ext4 file system. We can check the ID, UUID of the RAID by running blkid command. This is the UUID of our RAID, which we can use for different purpose. In case if we want to make an entry in the FS tab, we can obviously use this UUID there. Now let's create a directory by running the mkdir command, and let's mount it on RAID 0. We have successfully mounted the directory there on the RAID, and we can create the data there. Okay, so this is how we can create the RAID. Suppose I want to make one of the disks faulty, but before that I would like to show you the details of this RAID. mdadm -D/dev/md0. -D is for the details. This is RAID 0. We are using 2 drives here in this RAID. State is clean. That means RAID is working fine. There are no failed devices. And here we are using 2 similar disks, SDA and SDB. Suppose I want to make one of the disks faulty in this RAID. So I can execute mdadm command, mdadm /dev/md0 -fail /dev/sda. Suppose I want to make SDA disk faulty here. So we cannot make it faulty, because if one of the disks become faulty in the RAID, RAID will stop working. Our data will be lost.
Now connected to Vikas Nehra PC.
Okay, so we cannot directly make any of the disks faulty in this RAID, because this is RAID 0. In RAID 0, it cannot tolerate even one disk failure. Okay, if you want to stop the RAID, it's very easy. You can execute mdadm command -stop /dev/md0. So this will stop the RAID. But before that, you have to make sure that the file system is already unmounted. Let's unmount it first, and then we can stop the RAID. So RAID is stopped, and we can verify it by running cat proc md0 command. Cat proc mdstat. So there is no such devices in RAID 0. And we can check it by running the lsblk command as well. There are no RAIDs showing up for SDA and SDB. So this is how we can configure and manage the RAID. Now let me show you how can we configure RAID 1 and how can we keep some data there, how can we make one of the disks faulty, and how can we easily replace it, and our data will remain intact. So let's create RAID 1 here. mdadm, either you can use option -c to create the RAID, or you can write -create like this. -v, either you can use for verbose, or you can write -verbose. Then you can mention the name /dev/md0. Then you will define the level by using option -l, or you can write --level in full. Level is 1. Then you can use -n for the number of devices or the disks, or you can write here RAID -devices. And then you can mention the names of the devices that you want to include in this RAID. So RAID is successfully configured. Now let me show you the details. By running the cat proc mdstat command, look at this. RAID 1. Earlier we configured it RAID 0 on the SDA and SDB disks. So that is why it is showing the signature of RAID 0 as well. mdadm hyphen detail. Either we can write -D or we can write -detail to see the details of the RAID. Look, RAID level is 1. RAID devices are 2. All the devices are working. Failed devices are 0. And resync status is 47%. That means the data is getting synchronized on both the disks. Okay. Now let's create the file system on this RAID. We can either create XFS file system or we can create ext3, 4, whatever we want. This is already having the signature of ext4 because we already used it on RAID 0. So we can forcefully create the file system by using option -F there. And now we can check the UUID by running the blkid command. Look, XFS file system is there on this RAID. Now we can mount the directory on the RAID. Mount /dev/md0/RAID. Now let's verify the mounted file systems by running the df-h command. Look, RAID is mounted successfully there. We can create the data now. And in case if we want to make an entry in the fstab file, obviously we can make an entry there by using the UUID, or we can mention /dev/md0. Now let's go to this directory which we mounted on the RAID and let's create some data there. Let's create a file having the text as Nehra classes are awesome. This is just to verify whether the data remains intact or not. Okay, now we will come out from this location and let's check the details of the RAID by running the cat proc mdstat command. Look, active devices are SDA, SDB, unused devices are 0. And let's check the details by running the mdadm command. mdadm, either we can use -D for details or we can write -detail /dev/md0. Look, active devices are 2, failed devices are 0. And you can look at this, SDA and SDB both are showing as active. RAID state is clean. That means RAID is working perfectly. Now, what will happen if one of the disk becomes faulty? So we can manually make the disk faulty in this RAID. So these are the two disks, SDA and SDB, which we are using in this RAID MD0. Suppose I want to make SDA disk as faulty. How can I do that? I can execute mdadm command /dev/md0. That is the name of the RAID. Either we can use -F to make the disk faulty, or we can write here -fail. Then /dev/sda. So this will make SDA disk as faulty. Now let's check the details of the RAID by running the mdadm command. Look, disk state is clean. That means data is still safe there, but it is showing the state as degraded. That means some of the disks became faulty. And here you can see faulty device is 1. So out of 2, 1 disk is showing as faulty. Look at this. So what we will do in this case, if one of the disk becomes faulty in our RAID, we can easily remove it from the RAID. How can we do it? Let's execute the mdadm command. mdadm /dev/md0 -- remove we can write here, or we can use -r. It totally depends on your choice. And after that, we'll mention the name of the faulty disk which we want to remove from the RAID. So this will remove the disk from the RAID, and we can verify it by running the mdadm --detail command. Look, now the failed devices are 0 since we have already removed the faulty device, and here only SDB disk is showing up since we have already removed SDA disk from the RAID. Now we need to replace the disk with a new disk, with a fresh disk. So we'll go in the settings of our machine, and here we will create, or we will add another disk here. We'll select SATA, create a new virtual disk option, store virtual disk as a single file option, finish, OK. And now let's verify the disk by running the lsblk command. Now we have an additional disk, which is the raw disk of 20 GB capacity SDC that we can use here in the RAID. So we will have to add this disk in our RAID. How can we do it? We can execute the mdadm command. Then we'll mention the RAID name, that is /dev/md0. Then we will use option -a to add the disk, or we can write here --add. And then we will mention the disk name, that is /dev/sdc. So this will add the disk in the RAID. Now let's verify the RAID details. Look, active device is 1, working device are 2, failed devices are 0. State is resync, that means it is syncing the data with the help of the another disk, spare rebuilding. And after some time, it will show us 100% complete here in the rebuild status. 28%, 32%. And whether we have unmounted the file system? No. The file system is already in the mounted state. Can we check our data? Yes. Our data is still showing up here. Let's verify the contents of the Nehra classes.txt file. Look, it is showing us Nehra classes are awesome. That means the data is intact. This RAID can withstand up to 1 disk failure, and I've already shown you how can we make the disk faulty, how can we remove it, and how can we replace it with a fresh disk here. Look, 69% complete. After some time, 100% of the data will be synced. So that's it from my side in this session of RAID. Now, assignment for you. All of you will configure RAID 5, RAID 6, and RAID 10. And in each case, you will make one disk faulty and then replace it with a new one. So this is the assignment for you. All of you are required to configure RAID 5, 6, and 10. And in each RAID level, you will make one of the disks faulty and then remove it from the RAID and replace it with a fresh one. If you have any questions related to this session, you can ask me now.